right, well, welcome everybody. My name is Robert Mace. I'm the Executive Director at the Meadows Center for Water and the Environment. I'm also a professor of practice in the Geography Department. Both of those positions are at Texas State University. She'll probably make an appearance later, but right below my computer screen is a very demanding tortie named Lily. And so if you see my head kind of get chopped off, it's because she has leaned against my monitor and chopped my head off. So she's very furry. She's very concerned about the warming climate, what that means for her body temperature. Um, really want to welcome you all for joining us today to have a discussion with Dr. North about his book, The Rise of Climate Science, a memoir. Just real quickly on what the agenda is for today, I'm going to make some opening comments um, and and then I will kick it over to Dr. Andy Sampson, who is the founder of the Meadows Center, and as well as I think I can say he's the founder of the book series that we have. But he's going to go ahead and formally introduce Dr. North and provide a introduction and description of the book. And then we're going to give Dr. North a few minutes to go ahead and say hello and say what he wants to say as opening comments before we then go into kind of the formal interview. That's going to last about an hour, and then we'll have questions and answers for 30 minutes after that. Now, there and on Zoom, I'm sure probably at this point everybody's familiar with Zoom, but what's a little different about the Zoom for this meeting is there's a chat box. So if you just want to chat with people, of course you can pick people out and send them messages or chat with the entire group. You can click that and see that, but there's also a Q&A button, and that is where I will be looking towards questions that you may have for Dr. North. So as you're going along and you have a question that you'd like to ask him, go ahead and put them in there. Depending on the number of questions, of course, there's no guarantee we'll get to them all, but we will try our darndest to get there. So just want to talk a little bit about this neat partnership that the Meadows Center has with Texas A&M Press. We have a couple of book series, Conservation Leadership book series, and The Rise of Climate Science is the 10th book in this series, which is formally called the Kathy and Ed Cox Jr. Conservation Leadership Series. And we're deeply appreciative of their support in setting up an endowment to help defer costs with the preparation of these books. This series is sponsored by the Meadows Center and published by Texas A&M University Press. Its series is established to illustrate strategies and diverse approaches to foster protection of our natural world. Each book in the series aims to inform and inspire leaders to commit to conservation and includes an introduction. And the Meadows Center's founder, Dr. Andy Sampson, has provided those introductions, but he's passing the torch. So you'll see new authorship on those soon. Books are distributed through public and private sectors, as well as universities and communities, where they're used by reference tools for experts and policymakers. Since 2012, Texas A&M Press and Meadows Center has published at least one book a year. And again, to date, 10 books have been released in the series. To see the full collection, you can go to Texas A&M Press and look for the Browse by Series. You can also see the books in the series at the Meadows Center's webpage under Publications and Book tab. We also have a River book series, and it's also sponsored by the Meadows Center and published by A&M Press, and it was established to promote river stewardship and appreciation for our most precious natural resource, water. And we've been doing this also for quite a while and have been published at least one book every year, with 25 books published to date. Also just want to talk briefly about kind of the Meadows Center and climate change. You know, really excited that this book has come out, really excited to be here today with Dr. North. He and I met, and I was trying to figure out exactly when it was that we first met. I want to say it was maybe 2006 or something. Maybe even earlier. I want to say it was after the first state water plan came out that was focused on the regional water planning process. And you know, appreciated him stepping forward and asking, I think, what were some good questions about how come the plan doesn't talk about climate change or global warming and those impacts. I can say this now because I couldn't say it then, but you know, I was asking some of those same questions as that water plan was getting put together. That there would be somebody, and I didn't know who that somebody was going to be. It turned out to be Dr. North, that was going to say, "Wait a minute, y'all are kind of missing the boat here on this important issue that you know, really should be looked at." And so that's, you know, and as a scientist, you know, I certainly have been concerned about climate change. I'd say in part inspired by Dr. North's kind of comments, a book that he was an editor on about global warming in Texas. You know, was able to do some work while I worked at the state on climate change. And then the door slammed shut pretty hard due to politics that I'm sure we're all aware of, and just the general political situation. That political situation pretty much still exists today in Texas. When I reached retirement age from state government, that's right, I retired from the state. You know, my college buddies called me Babyface Mace when, when I was in college, because there was no way we could sneak into a bar if I was along. Because back then I looked like I was 5 years old. One of the things that I hoped to do was to kind of take a look at the climate change aspects in water in Texas. And so thanks to support from the Meadows Foundation, we're starting to do just that, in the hopes of creating a statewide downscaled data set that could then be used for kind of statewide analyses on the impacts of water resources. And then that information could be presented to decision makers, as well as doing policy analyses on what local, regional, and state authorities could do on climate change. In a way, it's working around the limitations that we have today. I do know from my personal experience working in at the state government level that, you know, there's people who are concerned about climate change, you know, political leaders, water managers, and whatnot, but they just can't talk about it or do anything about it because it's just unfortunately too much of a political hot potato. And I'm sure we will touch upon some of those things with Dr. North as we talk, because his fascinating career certainly has crossed those intersections. So with that, I'm going to then go ahead and kick it over to Andy for the introduction. Dr. Sansom.
Thank you, Robert. Thank you all. And thank everyone for being part of this today. I'm excited, humbled, and honored to introduce Dr. North to this first webinar in the partnership between the Meadows Center for Water and the Environment and A&M Press. I also found out today that it is the first book on climate published by A&M Press. Dr. North is one of the most, you're going to learn today, if you do not already know, that he is one of the most transformative figures of our time in this movement. He's originally from Tennessee, where he got his initial degree at the University of Tennessee in physics. His PhD was from the University of Wisconsin at Madison. I could list for you his awards and his publications, but they would take what we have devoted to this entire webinar today. But I'll tell you that he is very, very well known as one of the founders of this movement. He has, as Robert said, edited a book on global warming in Texas, which, as far as I know, is the only book of its kind. He's worked at some of the most prestigious scientific institutions in the United States, including Goddard, Oak Ridge, and Woods Hole. He led efforts to create one of the very first satellite-based systems to measure climate activity around the globe, particularly through rainfall. He served as chair of the Department of Atmospheric Scientists at A&M. He's now an emeritus professor there, and we are thrilled to learn from him today that he's going to be our neighbor in Hays County very soon because he's moving from College Station to Kyle. You're going to find in reading the book and listening to Dr. North that he has been a very courageous person. As Robert said, this whole issue has been a political hot potato, is putting it mildly. The last thing I will tell you before I ask Dr. North to begin the discussion today is that if you go to the Texas Legacy Project on the internet, you can find a spectacular interview with Dr. North that was made a number of years ago, but in listening to it, it's almost spooky the way things have turned out based on what he said when those interviews were conducted. So please take the opportunity when you have a chance, not only to read the book, but to find his interview in the Texas Legacy Project, which is in the Barker History Center, Briscoe History Center at the University of Texas. So Dr. North, welcome, and thank you again for being such a leader in one of the seriously most important movements of our time.
Well, thank you very much, Andy. I appreciate your support through the Meadows Foundation for previous projects that I've been involved in. And of course, I'm thankful to Texas A&M Press for publishing my book. It's very nice to see your interviewer, Robert Mace, who I've bumped heads with and shoulders with many times over the years. And with all those things, and also, of course, I appreciate Texas A&M University for putting up with me for 35 years, and other places that I've worked over time. And but to get started, I'm Jerry. Okay, so we don't have to be formal here. So just to get started, the book starts, it's a lot about climate science, but also a lot about me. I figured that my career was so weird that it would be interesting to people and perhaps inspiring to youngsters coming up, young scientists, young kids coming into college. And so a lot of the book is about me. And it really starts with my childhood. I was born just before the World War II, 1938, and my father was taken away in the war when I was just a very young child, and so it was very frightening for my mother. So I put a lot of stuff in about that because I'm proud of him and my uncle, two uncles. One was in the Navy, a gunner, and he was in heavy battles in the Pacific, and another uncle was in the Normandy landing. So anyway, so that had a huge effect on my life because my mother was terrified as he went across the Pacific toward Japan, got there just as the war was over, so he never really had to. Anyway, so there's that part. Coming up in a lower middle class home, working in a retail store where my mother worked, learning how to sail, very close to a Jewish family in Knoxville, and then on into college. And I've just my life is just a list of good luck decisions. You know, many times I've thought over this recently, how many times that I could have gone this way or gone that way. And well, of course, it wasn't all luck, but it would have been very different for me. And I'll mention a few of those. So anyway, I got to Knoxville's University of Tennessee, happened to be right there in my hometown. I had an old jalopy I took over there every day and parked. And I was, the tuition, by the way, was $52 per quarter. That included all fees. Kind of hard to imagine. And I do a little ranting about that in the book, about how things are really a little bit more difficult for young people like myself, as I were at that time. Going on to college, and how I worked as a co-op student at Oak Ridge National Laboratory, and then off to that's where I learned, working with scientists at Oak Ridge National Lab. I learned to really want to be a scientist, and I started in chemistry. I was a klutz in the lab, so that didn't work for me. So I moved over to physics, where I was a little bit more fitted for, and mathematics and physics were better for me. So I got to graduate school in Madison. A lot of nice stories there, and then on to postdoc at University of Pennsylvania, a couple of years. And I got, at this point, we're in the middle of the Vietnam War. All jobs for academic physics people dried up. There were no grants to pay for postdocs, nothing. So I was very lucky that one of my colleagues in graduate school had managed to get a job at University of Missouri, St. Louis, which, by the way, is a branch university of the system in Missouri, and somewhat like Texas State. Only I think Texas State's a whole lot better. So anyway, it was so I actually taught physics there for 10 years. On sabbatical, I went out to NCAR, National Center for Atmospheric Research, because the field that I was in physics was not working. You couldn't do it at a small campus like that. So from there, I went out to Boulder for a year and got into this field, climate change. So that was in 1974, long time ago. And at the time, it was climate science as a science was just beginning. It really became a science, I think, when it was recognized that climate and climate change, et cetera, are physics problems that have to be, you have to use the laws of physics to solve the problems. And so I and a number of other physicists actually came over to the field during the early 70s, middle 70s. And I had a very good time there. I wrote a couple of papers that got some publicity for me. I went back to St. Louis and so on. So I'm running through all this stuff, Robert, and you can pick some of it. There's too much to do in just a small time like this. But I got into going over to the Soviet Union. I was quite interested to do that. It was a communist country at the time. And because of my early work in Boulder, I was recognized that I was one of the early people trying to turn climate change into a physics problem. So we went, 15 of us went over to the Soviet Union, and we were there about 15 days. And that was quite a thrill for me. And I tell quite a bit about it. In fact, over the years, over those next 2 decades, 2.5 really, I went over a total of 5 times to the Soviet Union. And every one of them was of really a very interesting experience, but also learning how people in other countries did their research, how big institutions did their work, how did they get their power to get the money to do it, that kind of thing. So I became a kind of student of these institutions. So I went to for the summer at Woods Hole Oceanographic Institution right then, so forth. Andy, maybe, Robert, maybe that's enough to get it started. I'm gonna have to ask you to join in here.
Join in.
I will talk your ear off. Sorry, I'm an old professor, and I can't help it.
Yeah, that's in part why we're here. So that's fine. Yeah, and I'm glad you mentioned that. It is a memoir, and your career, very fortunately, started with near at the beginning of climate science, and then you've been there along for the ride along the way, and it makes for a very fascinating read. And I think it's also interesting that oftentimes we see the person, maybe we see you speak somewhere, or we see the paper or the report that you produce, but we don't see the backstory and some of the juicy details, which we'll talk a little bit about this afternoon. And so that's also a neat thing. And then there's also some things in there that now as an executive director at the Meadows Center, you make some comments towards the end of the book about kind of running departments and managing people and stuff like that, which I certainly appreciated in my current role. You mentioned earlier in your comments today about I call it, and I think about this too sometimes, there's like an element of randomness in life of, like you said, you make a decision or something happens that wasn't part of the plan, and it kind of steers you off in a different direction. And then off you go, and you look back and you're like, gosh, if just one little thing had happened differently, I'd be somewhere else working on Lord knows what. And so I really thought that was a good thing about the book, is like you said, kind of letting young people know that it isn't this, you're a successful, well-respected person, and it wasn't like, you showed up on the scene and had this master plan to get there. It's just, there's some randomness. You find out what you like and don't like, and if you don't like it, maybe you kind of look for other opportunities, and then you land one. I thought that was very helpful for kids.
Sure. Flexibility. Yeah, you have to be ready to go left or right or something at some point, instead of just sitting there and letting it happen. So that really was. It's just really amazing how lucky I have been, and also working with really good people. After that experience at NCAR, National Center for Atmospheric Research, years later, I was actually on their board of trustees and things like that. So I became, as I mentioned earlier, I became interested in these institutions and how they work, how they function, and how they change over time. One thing that was really interesting to me was how some laboratories, even in the private sector, hired scientists to just work on whatever they wanted to do. That's just amazing. And an example was Bell Labs. One of my colleagues in graduate school took a postdoc there, and he went on and had a great career after that. But that was a place where you can read a book or two about Bell Labs and how it was. It's just amazing. People won Nobel Prizes for the work they did there. And then suddenly it all broke up, fell apart. And, after a decade or two of what I often refer to as Camelot, when that was an example of one of them. And I've noticed that, when I was at NCAR, it was very free, just do whatever you want to do. And that really draws good people to come there and work together, so forth. When I went to Goddard Space Flight Center, 1978, there was that kind of atmosphere there, just amazing. And I was there 8 years, and by the time I was leaving, everybody else was leaving. So, because that was the end. That brief moment in the song about Camelot, that one brief moment, and then you have to clear out. Everybody clears out, and a lot of it is institutions like efficiency. They love it, and that's one thing. It's contagious. It goes to universities, government laboratories, industry, of course, private sector. Everything has to be efficient. And that's when you shut down a lot of long-term projects, things like that. The kind of work that you have to have going on. And you can only do it in universities. But even they now have stopped it with the use, and I talked probably too much about it, ranting toward the end of the book about metrics and how, in my opinion, that's not always a good practice. It's not bad, but it's not always good. There you have to look at the whole person, not just how many papers, how much money, how many students, how many, and so that's troublesome to me. But it shuts down the innovation and the wildness of thinking, and people come and go. So that's what happened. But I was very happy at Texas A&M all those years, but I can see it changing.
Well, those are interesting comments about efficiency, and it just seems like it's harder to find time to just think.
That's
and,
right.
and like you said, and be creative, and
Mhm.
and I know personally I just have to kind of force time to just think, but it's hard when you've got a to-do list
Yeah.
this
Yeah.
long.
Yeah.
I think one of the details I really enjoyed in the book, I mean there's a number of them, but that I certainly related to was the comment you made about college eating. When you're in college, and speaking about being busy, like when you're in college, you're busy as hell. And you made a comment and it made me chuckle about you wish there was a pill that you could just pop and be done with a meal, so you could efficiently
Get back to work.
get back to work.
Didn't have time.
Now, for me, when I was in college, it was a Pizza Hut, and I'm probably remembering this wrong, but it was like you could get 10 pizzas for $1. Maybe it was 10 pizzas for $10, and so it was just pizza, breakfast, lunch, and dinner, and just pull a cold slice out of our fridge and go.
Yeah.
Let's talk about you mentioned Russia, which it was very fascinating to read about your experience as a scientist with Russia. In a way, maybe you were kind of like the 007 of climate science,
Yeah.
but you weren't a secret agent. But there were attempts to recruit you, it sounded like. Tell us
right.
about that.
It didn't work.
As far as we know.
Yeah. Well, of course, I'd have to kill you.
Tell us about some of those experiences in Russia.
It was, I was, the first trip I made was with 15 people. And we stayed 15 days. I think it was 12, 15, something like that. I mean, they were the really top people in the field. It was just amazing. Nobody knew me. Actually, a few of them did. A couple of them did know my work. But, the guy who led the delegation was head of the Princeton laboratory and for climate and weather research, especially using big computers. And so he was the leader, Joe Smagorinsky. And then there were people professors from MIT, UCLA, Harvard, etc. And it was just amazing. So we were there, and the meeting was in Tashkent. So we first started in Moscow, and we were surprised because when we got there, it was a delegation. There had been a kind of attempt at warming the Cold War just a little bit between President Nixon and President Brezhnev. And so the idea was to bring these people over, and then some Russians would come to US. Actually, very few of them ever did get to come to US because the Soviets were so scared that they wouldn't come back. So that's how it started in Moscow. And so we got there and we sat around the table, and a guy came in who was a famous Russian glaciologist, and he was an older man, and he says, well, we hear from the CIA that climate change is happening, and we have people here, some people who believe in it, like Professor Budiko, and another one, a fellow who just took Budiko's job, by the way, he fired him, gave it to this guy, Boris Hinkov was his name. And he thought it was because the sun was brightening. And so there was this feud going on between the top guys right in front of our eyes. we were completely shocked by this. But first of all, how did they know about the CIA report and we didn't? That was an issue. Anyway, so then we got on the airplane, and the Soviet airplane, so their air, whatever you call it, anyway, Aeroflot, it was called, and we flew down to Tashkent, which is way far away from Moscow. And so we had a long meeting there. And so the translators, the young women were very interested in all of the Americans. And at the time I was single. I was divorced from my first wife. And so, I mean, they were piling on. they all wanted to be married to an American so they could immigrate. So that was an interesting twist. But we also got to fly down to a huge and very important glacier in Uzbekistan, and so that was a very exciting and interesting trip. In fact, the picture on the front of the book, this picture is, I took that photograph, and the glacier is right behind. Those are my colleagues on the trip, and I took that photograph.
Neat.
So that was really nice. And we also got another weekend. We were there 2 weekends. One, we went down to the glacier. The other one, we went to Samarkand and a couple of other cities that were on the old Silk Road. So very beautiful, beautiful cathedrals, mosques they were. So really, they were really good to us. And of course, we all knew that everything we did was being listened to. For instance, if you were in a room talking to some Russians or talking to some Americans, you just knew. I mean, everybody in the room would point up like this to the ceiling because there was a microphone up there somewhere. You couldn't see it. So, you know that anytime you made a phone call, you knew that was being listened to. And, the second time I went, I spent the summer. And I don't want to go on too much about the Russian experiences, but I spent a whole summer in Leningrad, which is now St. Petersburg. And, I would go into the laboratory every day, and I had an office, and my friends would come in, Russian friends would come in, and, I had cigarettes, American cigarettes, they love that. And so, when they came in, they would say, so we would take a walk outside maybe or something. And so anyway, many stories like that in the book. All the little idiosyncrasies of Russian life, and in the Brezhnev time. That's when the Cold War was pretty cold, but this was an attempt to calm it down a little bit. It turned out that not very many Russian scientists did come over, but over time, many of them came, and I lived in just outside of the campus of Goddard Space Flight Center, and I was then married to someone from there, and so they would come to our house, the Russians, and I was a civil servant, worked for the government at the time, and they would come over to our house and have dinner, and we had a very nice time visiting with them. And some of them, you could tell, you had to be a little bit suspicious. Wait a minute, this guy has a memory that's unbelievable. He's asking me things about my work, none of which was classified. So I was happy to tell him that all papers that I had written, and they were published openly. And so, but, he'd be taking notes, and he would remember. He'd say, "Oh yes, I read that in your previous paper," and so on back. So this guy had essentially memorized everything I'd ever done. So you had to be a little bit curious about this man. Some years later, many years later, he was actually murdered. He was murdered
Wow.
in Madrid. And it was not, the Soviets said the CIA did it. CIA said that the Russians did it.
Wow.
So that was, so there were some crazy things like that happened. But I have to say, I never was in any danger. And the CIA would come to visit me after I come back from a trip. They would stop in to say, "Well, did anybody try to recruit you?" And so, and actually, I don't think anybody ever did try to recruit me.
Cool.
So, so you could bring up something.
So,
I could go the whole time on any one of these little stops of
that's a good stopping point. That was perfect. Just a moment on a process check. Questions can come in on Q&A, and I am seeing them. Some are coming in on chat, and that's cool. I'm going to get to those questions at 2:30. Also, I received clarification on the agenda that we'll finish this discussion at 2:30 and then go to the questions to wrap everything up by 3. So I think earlier I was saying this discussion was going to take an hour. It's going to be 30 minutes, just so y'all know. Maybe a little more on Russia. One neat little spicy tidbit that you mentioned was, and then probably mischaracterizing this, but Stalin was a meteorologist.
One of the meetings that I attended was in Tbilisi, which is in Georgia, at that oblast at that time. Now it's its own country. So Stalin actually grew up in Georgia. He was Georgian, and he went to a seminary for I guess there is a Georgian Orthodox church, and so he was obviously very smart. So he went to the seminary, but I think he actually maybe even attended about 3 years, and he got tired of it, and he went over and got a job at the meteorological station there, and he actually took data and he wrote reports for them. But apparently he had a lot of free time, and he got interested in politics. and there's some really very good books about him, but one of them was Young Stalin, and I read that book and many other. I'm a voracious reader. It's disgusting, but anyway, we're having to move all of my books, by the way, as we move.
They're heavy.
But anyway, he did that for a short time, but they were bragging about it, and it was amazing. In taxis, you would ride a taxi in Tbilisi, and the cabbie had a picture of Stalin up on his mirror, with the hanging picture of Stalin. So, this guy was such a monster, and there were still people who loved him. Just amazing. Little something.
So when you were in Georgia, did you get to try any of their wine? They have some
Yes,
really
oh, yeah.
nice orange wines,
Yes, yeah, they have some really nice
kind of old
wine there.
school. Yeah.
Yeah, we went over to a place and it took us 4 hours to drive over there in a bus. It was very dusty. That's a long story. But we got to this place where they had all the grapes, and we had a huge meal that evening, and all of us had a little too much wine to drink. People's names that I left out in the book. Anyway, so that was a really great experience.
Yeah, I mean that was really fun reading that in the book. One thing I didn't know was, and I'm sure a lot of folks listening, there's the infamous hockey stick plot.
Yes.
Of CO2 concentrations that look like a hockey stick. They just kind of go along and then boom, they take off. And when that came out, that was controversial. I think probably both politically and as well as, I guess it was some question on the science side, since obviously I think it had some pretty big consequences on policy. And so was it the National Academy of Science that you were part of that did a review then of the hockey stick plot?
I was called by the president of the National Academy. We had met in Austin, by the way. He was, at the time when I met him first, he was the chancellor at University of California, Irvine. This is a nice little quick story about Texas. And George W. Bush had just been, H.W. Bush, who's the younger one?
W is the younger one.
W.
W? Okay.
Was, he was the just elected president. And his new Secretary of Commerce was Don Evans, who had been on the Board of Regents for University of Texas. And he had just become the Secretary of Commerce, and up was coming a new census. And so he discovered all of a sudden that it's in the Department of Commerce. Oh my God. And then he also found out, after being nominated and accepting the job, he found out that NOAA, the National Oceanographic and Atmospheric Administration, is also in the Department of Commerce. And so he asked the former president, I guess he was the president of UT, and he was a chemist, and he knew this guy, Ralph Cicerone, who was at Irvine, and we all met in one of the big hotels in Austin to have a discussion about climate change. And so I brought a copy of the book that you mentioned, or that Andy mentioned, about impact on Texas. So I brought a copy of it and I gave it to Don Evans. And so Ralph Cicerone remembered me from that meeting. And so when we became friends, and I was actually also worked with him as an editor and assistant editor on a journal. Anyway, so he asked me to please chair this committee to look into this issue of the temperatures of the Earth over the last 2,000 years. And so I had some experience in paleoclimatology, that is, climates of ancient times. And so we put together a committee, and it was extremely controversial because there were a couple of papers written right at the turn of the century, 1998, 1999, and they were very controversial. But in fact, they were new pieces of information that had been done by Michael Mann and two of his co-authors. And Michael Mann was already a very controversial person because he says what he thinks and how he feels. And so we took on the job of reading those papers, and it took a few years. Those papers were before the turn of the century. Our committee met in 2006. So there were a lot of papers that were also published supporting and arguing with their work. So, but what happened was politicians got involved. Our dear Congressman Joe Barton was the chairman of the House committee related to this. And anyway, so he pulled together a committee, but he didn't do it the right way. So others in Congress criticized him for it. And they said, let the National Academy pull together a committee. And so we did it. And I had to be the referee of a dozen people fighting it out. We couldn't figure out what the word consensus meant. And so, so the world by committee. Anyway, but it was a wonderful experience for me, and it worked. We decided that Michael Mann's work was correct enough that it was a first shot, and that's what happens in sciences like this. People write papers when they don't have proof yet, but sometimes it raises the issue. Others flock in, and a lot of progress is made. It's not like mathematics or statistics journals where you make a proof and it's you don't
deterministic.
until you proved it. It doesn't work that way in the rest of science. Most of the rest of science. Anyway, so it was a really interesting thing, and so I think, and I had to testify in Congress for 4 hours, by the way, sitting there for 4 hours while being grilled by both sides. Republicans were opposed to anything to do with global warming, and Democrats were involved in trying to prevent it. And this work that I'm referring to had some impact on that. It was not the thing that the smoking gun. It was not that, but it was an important piece of evidence in favor.
Your comment about scientists arguing about or not being able to come to consensus on what consensus means. It's, I'll have some friends who will, tell me that they think there's, scientists are in cahoots and in collusion to, have this view that humans are warming the climate. And my response is, you don't know too many scientists, do you? Because those discussions are intense. Yeah, I mean, you're fighting,
as a contact sport.
So that's interesting, and it is unfortunate that a lot of people don't understand science. Just your comment about just because a paper gets published doesn't mean that is it, but that
right now in the pandemic thing.
Yes, exactly.
People are sometimes, and it's like doing science in a fishbowl. Everybody's looking at you. Well, in that case, it had to be. People were dying for information. But you also have some crazy characters who are giving their opinion. And sometimes the media doesn't understand who's who. Most of the time, I think they get it right, but they pick people that they can really trust, and so then things settle down. I think by now, in the case of the pandemic, the vast majority of people understand what's going on. Have a pretty good idea. There are about 20% of the people who don't buy it. It's the same 20% that don't buy climate change, same people. And I feel bad for it. I grew up from people like that. I know them, I love them, but they're not, they're easily swayed one way or another somehow, or at least the ones I know.
I think, I think we all know folks like that. and so that's, inevitably the political component is there with climate science. And you mentioned George W. Bush earlier, and pardon the pun, but he had warmed up to climate
Oh, yeah,
change
he
towards the
did. He
end.
did some. Yes, he did.
And that created an opportunity even at the state. I published a paper with Shirley Wade at the Water Development Board on climate change and groundwater in 2008. But that door, soon thereafter, that door slammed shut as the kind of political pendulum swung pretty hard to the right.
In many cases, they call it the deep state, but there are people working on things like climate change, and George W. Bush actually allowed that to continue. He did.
Right.
He didn't, he did not want it to be publicized,
Right.
but he didn't shut it down.
Correct.
In fact, the satellite that I was involved with when I worked at Goddard Space Flight Center, they let that go. They let it happen. And so a lot of times I think the politician knows better. They know better. And so they don't want to shut this stuff down. They just can't take the publicity involved with it.
So I mentioned at the top of my comments about first meeting you while I worked at the Texas Water Development Board, and you came out after the water plan came out, and correctly noted that, boy, there sure isn't a whole lot in here about climate change, if anything. I think maybe the word was mentioned in there. I'm forgetting. I meant to do a search, and then I want to say my memory's a little faulty here, but I want to say the press kind of got a hold of some of your comments, and the agency invited you in. And I'm looking at one of the comments and one of the questions that somebody asked who was at that presentation. And it's a little tense because there were some folks at the Water Development Board that weren't real keen on the questions you were asking, and somebody was noting, I'd forgotten this, but was noting that I guess after some rather intense questioning at this presentation you gave, you made the comment, it's like, well, now I know what it's like to get waterboarded. Now, this wasn't in the book. I was kind of wondering when I was reading your book, I'm like, does he talk about this experience in the book? So either it was too traumatic, you couldn't put it in the
failure that I didn't get that in the book. I'm sorry.
Just curious what your thoughts are about that. Maybe in terms of where Texas is on climate change.
Everybody's coming along. Texas is gradually picking up on this, and the fact is, if you look at the temperature, I'm writing a book with a fellow about climate change, and it's a textbook, but if you look at, you can take all the cities from San Antonio, Austin, Dallas, go right up I-35 to Minneapolis, Kansas City, and then go across the country also, and just look at the temperature curves from each of those cities. They are just sort of bubbling along, till about 1960. Every one of them is going up, up, up. Every one of them. Every one of those cities, from San Francisco, Utah City, and so forth. I mean, every one of them is just going straight up. This country is warming, and it's exactly the same pattern for the whole world. I mean, sometimes it's going up faster on one side of the world than on the other, but then the next year or two, it catches right back up. So there's a lot of randomness in the thing, but there's this unmistakable trend for the last 60 years. It's actually it's twice that long, but there are bumps in the middle. As the planet was beginning to be just forced with this global kind of imbalance that CO2 does, it makes the whole globe coherently going up. You can see climate change, maybe in the past, there'll be one place gets warm, another place gets warm later, so on. So it's kind of random. And when you average around, it goes away. But what's really happening here is that it's a very coherent thing all over the world. It's going up, and the evidence for it, I do have a lot about it in the book. So if people want to learn about what I think about climate change, especially from the places that I visited, like Woods Hole, Oceanographic, Goddard Space Flight Center, and the space program and its connection, and then back to modeling climate, mostly at Texas A&M. So, so there's a lot of good evidence, and so I try to bring that up, because I really have been, as you said, from the very beginning. The very first big models of climate were being built when I was at National Center for Atmospheric Research, and also Princeton. So that's where the beginnings of the big models. I never worked much with the big models. Anyway, that I try to pull that together before people.
Okay, I'm gonna transition to some of the Q&A questions. And I don't necessarily plan on naming people who have asked the questions. I'm not sure they want to be named. But one question here is a former student of your graduate level climate change class is wondering is, and he doesn't seem too angry about the grade you gave him, but he's wondering, is there anything you do differently now in teaching your graduate level climate change class compared to a decade ago?
Yeah, there's more evidence. So, you know, that was a course I taught every summer for about 20 years. And it was 90 minutes a day, 5 days a week, and for 5 weeks. And so I gave them a lot of freedom, because I felt that these were usually master's or PhD students, and they had their skills courses. I was just making a download of information to them the way it is in the real world. When you know, that's how you learn. When you were at the water board, you learned when you went to seminars. That's how you learned. And the guy, nobody's seeing if you took notes or not. You either learn it or you don't. So anyway, but yes, there is, you know, in recent years, there's more data every year. More satellites are up. We know more about things. Certainly in the last 10 years, our confidence in the evidence and the impact of it has grown. The sensitivity of climate to a nudge in the energy balance is still really not known as well as we would like it to be known. So there still are uncertainties, but the uncertainties are somewhat narrower now. And in any case, the signal to noise, the noise being, you know, just the randomness of climate every year. But this trend has really moved up out of the situation if we had no CO2 increases. So it's well above. The signal to noise ratio is 2 or 3 or 4 now. You know, when I worked on this 20 years ago, we wrote papers about detecting this very weak signal. It's not weak anymore. It's really the two curves without CO2 and with CO2 are completely separated now.
It does seem like, you know, even during my career, that climate change deniers, you know, I think originally their first argument was, well, it's just the data is wrong, which is probably back in those days when, you know, the signal to noise wasn't as strong.
That's right.
And then, you know, and then it's turned into, well, this is a momentary thing. You know, we see cycles.
We've gone through those.
and then now it's turned into, you know, it's not human caused, which I would say is an admission that, yeah, indeed, we're seeing this year on year warming. I mean, it's hard. I mean, I don't think there's any Texan you could talk to. It's been around for a few years. It doesn't think it's been getting hotter.
Yes. Yeah.
Um, in the state, and
extreme climate extreme weather events. When you warm up the ocean, you put more water in the air, and then when that energy that cools the ocean sweats, and so the moisture goes in, cools the ocean a little bit, but then when it recondenses, it releases the heat. So that means rain events could be much larger, hurricanes could be more energetic, etc. So these things, Texans are starting to actually see it happen right before their eyes. I think many of them know it and understand it. So this is real. It's not made up stuff. And you know, if you were to show that this was wrong, you'd win the Nobel Prize. And you know, scientists starved for attention. That's what they want. They want to get awards and all that kind of stuff. They love it. And so, you know, if somebody showed that this was wrong, they would win the Nobel Prize immediately. I mean, the next year they'd have it. They wouldn't have to wait till they were 80 years old to give it to them. They'd have it that year. So it's. I think that it is. You know, there are some programs. There's one at Yale, another one at George Mason University, that look into the issue of communication of climate change, and what do people think. They do a lot of surveys, and there was one that I just opened this morning, you can put Yale University Communication Center about climate change in Google. I'm sure you'll find it. But what it shows is that around the world, the United States is actually a little behind. There is a core of people who are about 20% who do not think that it's real. and every other country, it's much less than that. And they have a bar graph of 50 countries, and they all say, yeah, we got to do this. The number one is Vietnam. You know, we're falling behind Vietnam on science. What is it? And you know, a lot of the old timers who were skeptics about climate change, many of them have retired sort of out of sight, or they've died. And this happens when a paradigm shifts. Usually the older people just can't believe it. They just won't accept, you know, going from classical mechanics to quantum mechanics. Even Einstein, he could never believe in quantum mechanics. But you know, then they die, and then it's the new paradigm just takes over, goes on. So that's the way it works. Some say, this is pretty cynical, but some say science advances one funeral at a time.
I've heard that.
Okay, that's not nice. I'm old enough I can say it though. Yeah.
You know, in my undergrad's in geophysics, and it's like plate tectonics. It's like that was hard.
Nobody believed that. Yeah.
Older scientists to grasp. Got a question here. It's in your opinion, what's the most immediate thing we should address to reverse climate change problems? I don't know if you have an opinion on that or not.
Well, I do. I say, and this is in the book too, that when a congressman asked me, what should we do? What I answered was, I'm a scientist. I can tell you what happened, and I can tell you what happens, I think, if you do this or if you do that. But I cannot tell you what the right thing to do is, because that's all mixed up with moral questions.
Yes.
Who pays, who doesn't pay, etc. But yes, I think. But now I can tell you my own opinion, which I can do. But I don't have any more authority on that than does Robert Redford or Jane Fonda or anybody else. But it's just my opinion, is that yes, we have to stop putting greenhouse gases into the atmosphere. We have to stop. And I don't like the idea of geoengineering, this idea of putting dust, and I talk about it in the book, putting dust in the stratosphere. I just don't think that's wise. We should just stop putting this stuff in the atmosphere. There are a lot of ways to do it. It's not all worked out yet, but I will be doing it soon. I'm optimistic. I think the world will adjust to this.
Yeah, I'm optimistic too. I think you know, my viewpoint is that things will start happening that and perhaps going to take some scary things to start happening that give people pause and then perhaps change direction. I mean, even Harvey, to a certain degree, did that. You know, both with Texans and with the political class. And I agree with you 100% on which is kind of why I said if you had an opinion, because you know science doesn't care. Is what I often put it. It's like science is science, and we're talking policy decisions. I mean,
we solve problems.
One potential policy outcomes, we don't do anything, and we adapt. I'm not proposing that that's on a personal level. I don't think that's what we should do. Although we're going to have to adapt because the CO2 cat is out of the bag to a certain degree.
It is.
Because it takes a while to get out of the atmosphere.
Don't let it get like guns. Too many of them, and now you can't get them back. So if you let it go too far, it may not be possible to back up. So that's a problem.
A question here is like, how much of the warming trend is winters being milder versus summers being hotter?
Well, you know, if you look at the data, if you take a place like where I live, and you live too, essentially the same place, if you look at the summertime, in the American South, if you look at the fluctuations of daily temperatures on a graph, you can find them on the internet. And it's very busy in the wintertime. The fronts pass, and that's the reason. So we have a front, it gets cold, then it warms up, then we get another one. And those are different from year to year and so on. But in the summertime, all the storms that give us the fronts, they move northward in the summertime. In the summertime, we don't have any fronts, maybe an odd one here and there. So what's happening is the signal is very clear in the summertime. So summertime is very clearly going up without very much noise because it's all just the radiation balance in the summertime. But in the wintertime, clouds, all that stuff going on, a lot of noise. It is going it's also warming in the wintertime, but it's harder to see in the noise. But in the summertime in College Station or Austin or San Marcos, any of those, or San Antonio, you'll see that it's true for the annual average, going straight up. It's about a 45-degree angle, the slope. It's really shocking.
Yeah, so it's scary. If you're not looking at the chat, and if you haven't gotten the book yet, until April 30th, end of this month, there's a discount code, Climate 30, and you get 30% off. So it's a 30 off of this book, and the link is in the chat, just to let you all know. A question, I think this is easy one to answer, is the unmistakable trend over the last 60 years is the hockey stick, correct? The trend in CO2.
That's correct. If you look at the data, I mean, the man et al., they were going back hundreds of years. And so they had ways of using tree rings and other things to estimate temperatures going back. And so the long handle of the, you can see my hands here, the long handle is the temperature slowly cooling over 1,000 years, 400, 500 years. And then all of a sudden, in the late 1800s, the temperature goes up. That's the blade of the hockey stick. And so it kind of rattles around there, and it's most prominent though just in the last 60 years. It's most clean in that short time. But it was going up, it's just noisier. You know, as the planet is being forced energetically, it has to adjust to the new trend. That's a physics problem.
One thing, you know, and I'm not a climate scientist, and I'm more focused on water. And so for whatever reason, I had missed this up until a year or two ago. But something that really caused my jaw to drop was CO2 emissions. What that plot looks like, and that's a scary
Yes,
scary plot.
it is.
It's similar. I mean, it's a hockey stick type thing, but it's
Yes, it is. You can find
sobering.
curves on the internet. They can take CO2 out of ice cores and go back 800,000 years, actually. But yes, it goes up exponentially right now. CO2 goes up exponentially, but the physics tells us that because the forcing by the CO2 goes logarithmically. So it turns out that what that means is the temperature should be a straight line. So CO2 exponential, just like the population. And but when you turn it into a temperature change, it's a straight line because it goes as the logarithm of the CO2.
Okay.
So straight line is what it should be, if this is correct. And it is. So
At some point, we're going to have to rename the hockey stick the Grim
Yeah.
Reaper Scythe or something, right? Because as it
well,
gets,
that's what I was saying in a court case not long ago, is that, you know, when this paper was published in 1998, the temperature was here. That's when they named it the hockey stick. But now it's got another hole
yes,
on the top of
yes.
it. The blade is as long as the handle on that hockey stick.
This is a real long question. I'm going to see if I can paraphrase it, and it gets somewhat geological.
Yeah.
You know, and if you look at the geologic record, there's there was a temperature spike in the Cretaceous, and again at the Paleocene Eocene thermal maximum, which both happened without humans. Then again, without humans, the world's temperature started a downward trend for 45 million years. Now we have temperatures going back up. Question is will we reach that thermal maximum again? And can we alter temperature cycles of our planet to prevent this? Which kind of relates to the geoengineering perhaps, or maybe it's just a question of can we really overcome these past cycles that we've seen in temperatures?
So yes, you know, if we don't do something, it's gonna keep warming. And you know, those some of those in all of the cases that the questioner brought up, the CO2 was the culprit. For some reason, geological reason, that one little peak that happened, I can't remember the name, but that one peak, there was also a big bump in CO2 at the same time. And there was, you know, 10 times as much CO2 in the Cretaceous and earlier. So there was a lot more CO2 in the air then than now. So
yeah, and I think my answer to questions like that is yes, there has been climate change probably since the Earth was a molten ball of lava,
sure.
But the real question is the change we're seeing now, is it natural or is it human forced? And evidence very strongly suggests it's human forced. And there's been some papers that have come out, analyses that have come out that said that because of the warming that has been induced by humanities, probably has staved off the next ice age from happening.
Takes about 100,000 years for it to come back all the way.
Yeah, well, you could argue we're kind of close to being due. I mean, if I'm remembering correctly, we were on a cooling trend before we went on this warming trend.
Yeah.
In the interglacial.
I think that was just a fluke. Yeah.
But it's but it isn't. I don't think we have control over those larger trends, but those longer trends are much longer. And I'm not sure, the fact that there's been far warmer temperatures in the past is a reason for us not to consider doing something about what it is that we're doing.
I'll just say this: what happened in the data about the warmer periods they're all really quite consistent with our climate science as we understand it now. And so I think you try to understand why this happened, why that. We actually, the ice ages that have gone up and down about every 100,000 years, that is not fully understood yet. So there are still some mysteries, and it's somewhere tied up in the glacial physics and other things that we don't have. We're getting more data all the time. I just read a paper yesterday about the Arctic Ocean, and there were a lot of times, even at last glacial maximum, there was a lot of open water in the Arctic.
Mm-hmm.
Very interesting. So what's going on? Warm water comes up through the Bering Strait and keeps it warm, even in the biggest ice age from in millions of years. There's still open water up there, north of Alaska. Amazing. Anyway, go ahead. Sorry.
So it's a question on how can scientists regain the general public's trust?
Well, I think that I think we just have to try to do our best in science, and I think that people eventually catch on. That we're doing it right. When you model air, the atmosphere, and so on, well, you just take it for granted that we know how to do turbulence theory enough to make airplane wings that cause airplanes to fly. It's the same kind of numerical models that we use to do weather. It's the same kind of mathematical procedure that you learn how to code on a computer. So
yeah, I think if
just keep doing the right thing, people will come along.
Yeah, and I wonder, and it's not a popular opinion these days, but and this kind of goes back to your statement about your opinion and versus science, but it does worry me when scientists come out and make strong policy or express strong policy preferences. Because I think to the public, it shows that there's the potential for bias. And even myself, when I'm evaluating, people, it's skeptical, and I hear them express a policy bias. Well, then I'm like, okay, well, how is that affecting their work? So on one hand, my sense is keeping the science and then, let the policy people handle the policy. On the other hand, it's, if you're scientists and you look at what's happening and you're concerned about it, you may morally feel that I need to go out and talk about this in a way that captures people's attention to do something about this and get specific about what has to be done. I like to say that scientists are at a great disadvantage in these public policy debates. It's like going into a knife fight armed with nothing but a pocket protector.
It's
Because
asymmetric.
Yeah,
Asymmetric.
it's a horribly asymmetric because you're dealing with money, people's livelihoods, and political preferences, and and
Became an
and
animal.
there is a tendency for people in general to want to maintain the status quo of lifestyle or how they're living, and so and I see that in water issues as well. With water conservation, trying to get people to conserve water can sometimes be difficult. We've got 5 minutes left, so I'm going to ask you one last question before we wrap up.
Mhm.
Looking in your crystal ball, this is an opportunity to end on a positive note. Looking in your crystal ball, what do you see future for Texas and in climate change and in dealing with climate change?
I think that Texas is a great state, and I believe that they can be convinced that science is good, and so there is the people who put most of the CO2 in the air are not the folks out in the countryside. They're the people in the cities. So we have to face up to that, uh, so we have to recognize that some people are much more slow to buy into this when their life is different from most people who are in the science business or the Meadows business or whatever. We need to think about how this can be done that brings everybody along, and so that's one thing. But I do think I'm optimistic. I believe that folks will uh, come to believe in what we are saying, um, and so I think that I'm optimistic. But we do have to act. And people have to act, and people have to stop disinforming. That is just a terrible thing that we're going through. I believe it's just a moment in history when this kind of thing is happening. But we need to tell the truth every now and then. People who know the truth. I mean, I think a lot of people are telling lies, and they know they're telling lies. They want it for power or one reason or another, but I think we need to hold people accountable for not telling the truth. That's just it.
Very good.
When you go to a doctor, you want to go to somebody who knows something about medicine. You don't want to go to a faith healer or something like that. We all know better than that now. Almost all of Texans know better than that. So, we need to just pull in more of science and understand that science really is not moral. It's moral leaders who have to guide us in moral matters. Um, but I do believe that if a scientist wants to go out and take a political position, Michael Mann is one who's done that. I think he has the right to do that. But not all of us do it. I don't. I do some. I warn people sometimes, but I don't tell them what to do. I think that's somebody else's business. Yeah, so I think that's my feeling.
Very good. Well, thank you so much, Jerry, for spending part of your afternoon with us. Want to thank the attendees and the folks that submitted questions. We did get a few questions in I didn't get to. Apologize for that, but thank you so much for those questions. Want to thank Texas A&M University Press for putting out the book. And also want to thank Anna Huff, who is kind of our communications person at the Meadows Center for Water and the Environment, who helped put this all together and have it work very, very seamlessly. So I certainly want to thank her for that, and then thank Dr. Sansom for introductory remarks. Y'all have a good rest of the day. Hopefully we've given you something to think about. and look forward to seeing you at the next book. Thank you again, Dr.
Thank you.
North.
Thank you very much. And thanks again to Anna and others who helped on
Cool.
this.
All right.